Imagine a region in space so vast and so empty that even astronomers were terrified when they first looked into it. A place where the usual cosmic tapestry of stars and galaxies simply vanishes, leaving behind a profound and chilling darkness. This isn't science fiction. This is a real place in our universe. It's not a black hole, but something far, far larger. We're talking about a giant void that stretches an incredible 1.5 billion light-years across the cosmos. To put that into perspective, our own Milky Way galaxy is only about 100,000 light-years wide. You could fit 15,000 Milky Ways side by side across this emptiness, and you still wouldn't reach the other side. How can such a colossal hole in the universe even exist? To understand it, you have to picture the universe not as a random scatter of stars, but as a giant, glowing spiderweb. This is what we call the cosmic web. This web is the large-scale structure of the universe. In this cosmic web, matter, both the normal stuff we can see and the invisible dark matter, clusters together. It forms long, glowing filaments and dense, bright nodes where galaxies are born and congregate. Think of these filaments as cosmic superhighways, bustling with galactic traffic. But if you have threads, you must also have the spaces in between them. These spaces are not just empty. They are massive, under-dense bubbles left behind as gravity pulled matter into the filaments. These are the cosmic voids. And the giant void, also known as the iridinous supervoid, is the biggest bubble of them all. It's a lonely, silent desert in the middle of a crowded, chaotic, cosmic city. Now, when we say void, we don't mean it's a perfect vacuum. There are a few galaxies inside, but they are the loneliest galaxies in the universe, drifting alone in the immense dark, with no neighbors in sight. One of the most bizarre things about this void is what's happening inside it. Because there is so little matter, there is also very little gravity to hold things together. The mysterious force known as dark energy, which is pushing the universe apart, has a much stronger effect here. As a result, the void is actually expanding faster than the rest of the universe. This rapid expansion acts like a cosmic bulldozer, pushing the surrounding galaxies and filaments away, making the void grow larger every single second. It's a bubble that's constantly inflating, stretching the fabric of space-time within it. Scientists believe this supervoid is directly responsible for one of the biggest mysteries in modern cosmology, the cold spot. This is a mysteriously cool area in the cosmic microwave background radiation, the leftover heat from the Big Bang. When we map this ancient light, we see it's incredibly uniform, except for this one unusually cold patch. For years, scientists had wild theories about it, from exotic physics to even the signature of a parallel universe. But the supervoid offers a more plausible, though no less fascinating, explanation. Light from the early universe that travels through this void loses energy. As photons enter the void, they get a little gravitational kick. But because the void is expanding so fast, by the time they leave, the walls are farther away. The photons have to climb out of a shallower gravitational well than the one they fell into. And this process saps some of their energy. So, when this light finally reaches our telescopes on Earth, it arrives slightly cooler than light that traveled from other directions. The giant void is literally casting a cold shadow on our view of the Big Bang. Imagine what life would be like for a galaxy inside this void. It would be a vastly different existence from our own Milky Way. We live in a crowded neighborhood. We're part of the local group, and we're on a collision course with our massive neighbor, the Andromeda galaxy. These galactic collisions and mergers are common in the dense filaments of the cosmic web. They twist and distort galaxies, often triggering furious bursts of star formation. But the galaxies inside the giant void live a life of peaceful isolation. Because there are no neighbors to crash into, these lonely galaxies often keep their beautiful, fragile spiral shapes perfectly intact for billions of years. They are like pristine cosmic fossils. They also hold onto their fuel, the vast clouds of gas needed to form new stars for much longer. Instead of a wild, chaotic youth, they experience a slow, steady burn, forming stars at a leisurely pace that can last for eons. Now, let's take it a step further. What if you lived on a planet orbiting a star inside one of these lonely galaxies? What would you see when you looked up at night? The answer is ... almost nothing. Your night sky would be an ocean of almost complete black. The stars of your own galaxy would be there, of course, but beyond that, darkness. You would need an incredibly powerful telescope just to see your nearest galactic neighbor, which could be millions of light years away, appearing as just a faint, fuzzy smudge. The grand spiral of Andromeda that will one day fill our descendants' sky would be completely invisible. You would live in a universe that feels profoundly empty, unaware of the bustling cosmic city just over the horizon. This profound emptiness doesn't just boggle the mind. It also challenges our best computer simulations of the cosmos. According to our leading models of how the universe evolved, a hole this big shouldn't really exist. The random quantum fluctuations in the very early universe that seeded the cosmic web just do unseem to produce voids of this scale. So, how did it form? The leading theory suggests that in the very early universe, this particular region started out with slightly less matter than everywhere else, just by chance. It was a subtle, almost imperceptible difference. But over billions of years, gravity amplified that tiny initial deficit. Gravity from the denser regions surrounding it acted like a cosmic vacuum cleaner, pulling matter away from the underdense area. Filaments formed and grew, and the galaxies within them pulled on each other, hollowing out this massive cavity in space-time. It's a stunning example of how a tiny initial condition can, over cosmic timescales, evolve into one of the largest structures in the entire universe. The story of the giant void isn't just about the past. It's also a glimpse into the distant future of our entire universe. As the cosmic expansion continues to accelerate due to dark energy, these voids will grow and merge. They will eventually dominate the cosmos. The filaments of the cosmic web will be stretched so thin that the galaxy groups within them will become gravitationally unbound from each other. Eventually, galaxies like our own will be left as isolated islands in an ever-expanding ocean of nothingness. The night sky for future civilizations will look just like the sky from within the giant void today, empty. In a way, the giant void is a time machine, showing us the eventual fate of the cosmos. It is a stark reminder that nothing is actually one of the most significant and powerful. It shapes the cosmos, drives its expansion, and writes the final chapter of its story. Thank you for joining me on this journey into the heart of cosmic emptiness. If you found this as mind-bending as I do, be sure to hit that like button and subscribe for more adventures into the deepest mysteries of space.